So welcome everyone. I'm very happy to be here with you today. So a few words about myself before we start. So I have a PhD in particle physics, even if I have not done any physics for something like 8 years from now. But after that research period, I actually started working in industry as data scientist or data engineer, using mainly Python as a programming language. I started actually wandering in the Neo4j community in 2019, where I built the NeoMap application, which is a React.js based application to visualize spatial data stored into Neo4j into a map. I also authored a book about graph analytics with Neo4j, where we have an update coming next year with the new feature of the Graph Data Science Library. So for the past years, I've been working in a startup called Smart Grid, where we are trying to build a digital twin of the world, modeling all the entities and the relationships between them. And since a few months, I'm also working at GraphQL, so nice team with doing a lot of Neo4j. So back to this talk. In this talk, basically, we are going to build this. So this is the way I started thinking about the project, saying, okay, I want the code to look like this. And then I step by step implemented the different features. And that's the path we are going also to follow during this talk. So first, let me give you a bit of context and explain why I had this crazy idea of building a new OGM. First, though, when I started working at Smart Grid, we started from scratch. And so it was natural for me to use Python, which was the language I was more comfortable with, and is also good for prototyping. So that was easier. And at the same time, we had quite a complex graph model. Well, complex means that we had very unstructured and exploded model. Exploded meaning that to build a given object, I had to do multiple hops into the graph to retrieve all the attributes that were important for me. The reason for that is that we had to track a lot of things like user changes and all of this. And that ended up with very bad query performances, like 2 seconds for a given request that was not manageable even for a prototype. And at the same time, we all know that thanks to Cypher, we can actually perform queries that that perform multiple hops and retrieve the data that we are crossing during that path. So the question is, can we take advantage of this Cypher feature in order to reduce the number of queries and improve a little bit the performances of our request? So when you work with Python and Neo4j, you probably have heard about some of these tools like NeoModel or Py2Neo, which both contain an OGM part. Or, for instance, I also crossed another tool that is Cypher that lets you write Cypher queries, but only using Python. So you have an example in the terminal in this slide, for instance. But Cypher doesn't have the object mapping part. And from what I could see in NeoModel and Py2Neo, it was not possible to retrieve the thing that was important for me, so to retrieve multiple objects in one single hop. So that's why I basically decided to do and kind of write my own tool. First, because it was a requirement. Second, because it was also important for me to understand how those tools are working. So the requirements were so to be able to define a node with some properties, match a node based on property values. And the last one was the most important, so prefetch some related node on demands. So for instance, when I query a movie, I also want to fetch the actors of that movie in the same query. So in this talk, we are going to go through step by step. The code is already available on GitHub. I confess I will not have time to discuss and explain every single line of code one by one, but you will have the opportunity to watch the code afterwards. So we are going to use the dataset, the movie dataset, the movie graph, which is a well-known graph, using the movie nodes that have a title and the release properties. and the person node with a name, and the two properties that are circled here, so the acted in and directed relationships. So let's get started and go to the code. So here you can see that the only requirements that I have are the Neo4j Python driver, and I'm also using PyTest to write some tests and see that everything is working as expected. So if I start by writing tests, what I want to be able to do is to define, for instance, so here a movie class with a title. Those properties need to be set, and then I want a function that is able to basically create this create statement where I want to create a node with a movie label and set its properties, right? So the easiest part, of course, is to write a movie class with title and release attributes that we can set, and we can build that function here that return the query as we expect it to be. As you can imagine, you will have to repeat the same function for every single node label that you have in your graph. So build, create, person query, and so on. And the same for match, which might be quite complex in the end. So my idea is to change a bit this, and while still having the same, actually the same properties, so the same test, we can build a class that this time looks like this. Okay, we have a movie class that inherits from the node class and defines two properties, title and released. So here I do not want to go deep into the details of how it is implemented, but there are two important things to note. First is that the node class and all its inherited classes will be built from a given meta class in Python. And the goal of this class is to analyze what are the attributes of this class. And as you can see here, if the attribute is an instance of a property, it will be saved. And the important thing is that all the nodes subclasses will have an underscore properties attribute that contains a property dictionary with the name of the property and the instance of the property attached to it. So that's one thing. And once you have this, you can imagine it will be easier to build all the Cypher queries we need. The other thing I want to show you is how this property actually works. So it will actually, there are actually two functions or two methods that are important, which are the set and get function here, which are the function that will be called, for instance, when here you're setting the title property on a movie object, then this is the set method that will be called. So there are a few advantages of using this pattern here. One of them is that you can add properties into the property class, right? So you can, for instance, define here is required and change the behavior of the property if this property is actually a required property. The other thing is that when you set a value here, you can have a behavior that depends on the property. So you can imagine creating different subclasses of a property, like an integer property or a date property, and you can validate the value that is passed to it and raise exception if it does not match the value you're expecting to see. Okay, so if we check here our tests, you see that I have now a build create query that is a method of the node class. And this method will actually use our underscore properties dictionary that in order to build the set statement. So the last part of the query here. And that's basically it for this part. We can also do something that was not possible before, which is we can raise an exception if we are passing an unknown property. So if we are trying to build a movie with a property that is not declared in the class, we can decide that this won't be stored into Neo4j and to raise an exception if we try to create such an object. So let's go ahead, and now we are able to build the create statement, and let's see how we can actually do the same for the match statement. So here I have the exact same test as before, and I'm just adding some tests to actually build this match query. And this actually is very similar to what we have done before. We are building the match statement in this class. So this is the main difference compared to what you have seen before, that instead of building all the Cypher query into the node class, I have extracted that part, all the parts of the code that build the Cypher query into a node manager. And this manager is actually attached as an attribute to all the node class here. So it's called Q for query. And what it changes is that now, in order to access all the create and match query, we will have to use movie.q.create query or .match query. So that's just a matter of organizing the code at that stage. And we can see, so here I just repeated the create queries, and we also have the match query that we'll use. Here you see that it uses the class name, the class name as label. And we have the where statement that is built in the same way using the filters that are passed to it that are joined with only an AND operator. And we are returning the node. So in the end, the match statement looks exactly like this. And actually, we can test. I haven't shown you so far, but all the tests here are actually passing, right? And the same for the match query. If we are trying to match a node from a non-existing property, then we will have some errors raised. So one thing I want to show you here and is that, so instead of returning directly the node here as we're doing, we can change a little bit that query and take advantage of Cypher map projection to return directly only the properties that we're interested in as a JSON object. So let me share one sec the Neo4j browser, and we'll see. Here we go. So Cypher map projection are actually very convenient, especially when you're trying to build this kind of OGM here. Oops, where is my code? So here it is. Up. And what we are doing usually is that we are doing this, and you see that the object returned is a complex object with all the information about the node. And when you use the Python driver, it returns an object of type node. What we can do instead is using map projection, for instance, like this. And you see that here the object returned only contains, is basically a JSON containing only the properties that we can also configure and to return, for instance, only the title. And we can also add some computed properties like the node ID in that way. Okay, we are returning only the properties we are interested in. So let me just show you why this is interesting. I'm just taking a bit of advance compared to what I want to show you. The very important thing, and that we will definitely use in the following, is this ability here to, in the map projection, to follow some relationships. So here I'm starting from a movie. I want to return this movie title. And in the JSON I'm building, I will add an actor's key. And the actors will be built from this pattern here. So from the movie node, I will follow the relationship acted in until all the persons that match that pattern. And for each person, I will actually extract the name property. So if I execute that query, you can see that I have a JSON with the movie title, my actor's key, and the actors contain a list of nested JSON with a name. And what is even more interesting is that this pattern that we are building here can be nested. So I can follow again the relationship from the actor's person to, for instance, the movies that that person directed. Okay, this is what is done here. I'm extending the initial query, which is still the same. And for each person acted in a given movie, I follow again the relationship towards the movie that this person directed. And here I obtain another nested JSON, still with the Cloud Atlas movie, all the person that acted in that movie. And you can see that, for instance, in our graph, we have the information that Tom Hanks, who acted in the movie Cloud Atlas, also directed another movie. So we can follow relationship in that way. So let me go back to the code. Sorry for the time to switch window. Yeah, so here we are. Now, so we have our node definition. We have our match and create statement that are working based on the node definition about itself. Now we are going to implement the properties. Okay, so now we are actually using another test. So here still I'm fetching my movie. And now what I want is that when I access the actors, doing movie.actors, I want actually to retrieve all the actors of the movie. And if I access the actor's name, I want them to be actually implemented. So let's see how this is done. So I actually added, compared to the code before, one person node with a name property. And in my movie class, I've added this relationship property that has a few information, so the relationship type and the target node label. So both of these information are required in our object graph mapper. You know that in Cypher, you can build a pattern without specifying, well, either the relationship type or the target node label. But for us, this target node label will be important in order for our code to know which object needs to be instantiated when we are actually calling the .actors. So here, each of the objects in that list should be an instance of a person. That's why this information is required in our case, which is not necessarily the case in Neo4j. So let's see how we implemented this relationship property. So a relationship property inherits from property, so it has the same structure. It has those parameters here, so a type, a target node label, and an optional direction if we want to enforce the relationship direction. And when we are trying to actually get the relationship, which is what we do when we call this famous movie.actors. It first checks if the property already exists, is already cached, in which case it will just return it. And if not, it will fetch the data. And the fetch method is implemented here. So we are basically building the pattern, right, from a start node, the relationship pattern that we are building from the relationship type, and eventually, or maybe the direction that decides on the direction of the arrow, as you know in Cypher. And then we are building the target node pattern, which is the famous bracket node and node label. And we are returning the target nodes and with all their information and their ID. And once we have this, we are actually, for each result, for each node in the target node class, we are actually hydrating the node. So that's one thing I've not told you before, but actually the node itself is responsible for creating and instantiating instances of itself. This is not required. And you can see that we are iterating the node here from the data coming from Neo4j, and it returns an instance of itself. So that's what we are doing here. We have the target node class. We create an instance of this class for each row in the result set, and we are returning those two rows. So if we actually run this, we can also test that it's working as expected, and that's fine. The problem here that we have is that, as you can see here, so I'm using a special transaction object that is able to track the number of queries that have been performed during that transaction. And you see that we have actually two queries performed, one for the matching the node, and another one, the one we have just seen, to fetch the actors related to this node. This is actually what I want to avoid. So in the next part, what I'm doing is actually I have almost the same code here, but I want to be able to only perform one query. So I want here my query to return only one, my number of queries to be one. So if I run this, we'll see that actually this test is failing. We will see what are the changes that we need to make in order to make it work. So first, we want to specify what are the fields that we want to return in this in the match statement. So I added this parameter here in the match clause that says, okay, I want to return the title for the movies, and I also want to return all the actors. We are actually propagating this return field to the function that builds the match query here. And in the match query, we are passing this parameter to the part of the query that builds the return statement here. So here again, the code started to become quite complex. So I've extracted the code into another object that is just meant to build the return statement. There are actually two reasons for that. One is that the code is a bit cleaner, a bit more organized, at least. And the other reason is that, as you have seen before, we can iteratively build the map projection pattern, adding deeper and deeper relationship. And so we will have an object that is actually calling itself with another set of parameters. And so it's much easier to have a different object. So for now, what this object is doing is that exactly as before, it's returning only the node and its properties. There is no relationship extracted from there. But we are actually going to use this code here. Where we are building the query parts here. So this code is a bit more complex and probably can be maybe simplified again. But the important thing is that it will iterate over all the fields that we are providing. So the fields we want to fetch together with our starting node. And depending on whether the field belongs to the model properties or to the model relationships, then we will append a different part to our query. So if it's just a field, a property, we can append just the field name like this. If it's a relationship, then we will have to build the pattern and to extract all the information from the target node. So what happens if we run this? Okay, if we run this, it's actually failing again. And I know why it's failing. The reason for that actually lies in our hit-rate function here. So if you remember, okay, I know I've only shown it quickly, but it's actually using only the properties. It's not taking advantage or reading in any way the relationships of our class. And that's what we are going to fix right now. So now my hit-rate method is also reading the relationship parameters and adding them to the node data before creating an instance of that node. And we also need, in the same way, to update the initializer class here. And this time, we are working fine. Okay, we have one warning, but all my tests are passing, meaning that this time I have managed to actually fetch the movie and its actors in only one query, because when I actually use that line here, movie.actors, the actors are already fetched, already filled, and I can use the cache results. So that's it for the code. So we can go back to our slides. And yeah, so when we have this, so you can imagine we can extend this code even more, doing some multiple hooks. So that's, for instance, what you can see on the code block on the upper right corner, where we are using this double underscore notation to fetch the actors underscore directed, for instance. So that requires to parse this and build our relationship pattern iteratively, but we have almost everything we need in here. And you can imagine that starting from there, you can also build a more complex match. For instance, building also a relationship pattern and filter on the related object. For instance, if you want to fetch a movie whose actor was born before, I don't know, 1960 or something like this, we can add the ability to filter on operators to build more complex where clauses, adding or, for instance, or clauses, and all of this. And also very important is that once you know what your classes are made of, you know your nodes, you know the properties and the type of properties, whether they are required or not, you can dynamically and automatically maybe build a GraphQL schema that corresponds to that to your node code, to your code. So this is an exercise I did, but the code is way too messy to be shared at the moment. Maybe one day it will. So that's it for this talk. So I put here some links. So first is a Cypher map projection blog post I wrote explaining how this works. Again, this is the code for the code that you have quickly sometimes seen today that you can go through and run it. And finally, so the code I've shown today is actually extracted from a bigger project. I'm actually working on to try and clean it and make it public. So it will be public at some point in this repository, but if you check it for now, it will be empty. So last but not least, I just want to tell you a bit about some talks that my colleagues at GraphQL are giving at this conference. So the first one are already done, but you can still wait for the recording. And I can only encourage you to listen to Federica and Alessia on one side and Fabio on the other side this afternoon. They are describing super interesting use cases of graphs and Neo4j. So that's it for me. So I think we may have time for some questions. In any case, if you want to reach out to me, you can still find me on Twitter. Thank you.
Thanks a lot, Estelle. That was great. I love this presentation. Yeah, I'm just scanning if there were any questions. So, like, without any specific order. Oh, I tried to show. Oh, people clap too much. How can we help, for example, if you take contributions?
Well, good. I mean, I think it will. I will try to make this public for sure, and then there will for sure be some tests to be done. I mean, if you're interested and you want to contribute and add stuff, you will be more than welcome. Then at some point, I mean, we already have stuff for Python written, so I'm not sure it's worth creating yet another object graph mapper. It will be maybe more clever, maybe, to try and add and see. The reasons why I started this are mainly the ability to prefetch some objects and see whether we can add these features to existing tools such as NeoModel, for instance. That could be maybe more clever than creating yet another tool. That's to be discussed for sure.
All right, thanks. Just a second. Open source at yeah. So you get a lot of claps for your talk. Just to give you direct feedback on this. Yeah, it was perfect. Thanks a lot. Yeah, and I hope you stay around in Hopin so you can answer follow-up questions. Right now, there's nothing. Nothing more. So yeah, I hope you will have fun with the conference again. And stay tuned for our next talks.